How are we doing, folks? So we're back on the SL, under SL125. Just going to do this feasibility study about possibilities of seeing if the alternator can possibly deliver some current at 12 volts. So got a few bits and pieces, so let's have a look. So this is the original battery, 6-volt battery. I'm not sure what amp hour it is. I'd have to check it, but this is the one exactly the same size to replace it in 12 volts, and it is a Vertex is the brand, and it is a VP3-3B in brackets, 12 volts, 3 amp hour. So it's an AGM battery, absorbed glass mat battery, and it's going to fit exactly in the slot without any modifications. So I have got a 12 volt coil which should fit in the same spot as the original, and it is one for points, because they are different. I think it's 4.6 ohms or something like that, the primary resistance value, and stripped out ready. We just need to separate this because I want to pull these phases out. But what I have done, I had a little look. So there's the generator or the alternator. So I've done a slightly different, a bigger drawing. So the 3 wires that come out of it, pink, yellow and white, there's some ohms values. So it looks like they're kind of like wired series parallel somehow. So obviously, no, the white and the pink would be the mains, and whether you could join that on to one of the phases, or whether a 3-phase. I mean, I've also got a couple of different regulators, so I could try them, but let's just separate these on here first and just see if there's any AC values coming out. So let's set you up and we'll see if we can get these terminals out of here. So I'll be back in a second. So here's our alternator output. I have marked everything, and this is our 3 connections out of the alternator. Obviously there's 4, one of them's the neutral indicator, but you've probably seen these things before. This one's blue point, I think. But if you use the appropriate tang, you can feed down the back of where the little tangs are, and you should be able to pull out. There's 1. The appropriate connectors, there's 2. There's 3 and 4. So there's our plug separated. This one we're not interested in. We can tie him back like so. Come on, baby. So he's out the equation. Not that we're going to get confused. We can, but and there's the 3. So let me just set up a bulb and we'll see if we can do some AC. You know, just seeing how well the bulb lights up. And then we'll try a couple of different rectifiers, see what we get. So back in a second when we set up. See you in a sec. Okay, we're hooked into the pink or red, whatever it is, and the white, and the yellow's left redundant. But if I put the yellow with the pink or red, it pulls the voltage down, but if I add this to the white, it brings it up. So let me just shut this down. So I think the thing is, it's going to be a single phase rectifier using the pink or red, whatever it is. I'm going to say pink. The pink one and the white one in conjunction with the yellow touching the white phase. Looks like it's going to give us the maximum output. So I think I've got a single phase. I've got two 3-phase, but I'm not going to use 3-phase. I'm going to go for a single phase, because it's only a single phase on here anyway, rectifier. I think this is just for the lighting circuit, and it's obviously out of step for the phases if you try and mix it with the pink one. So let me dig the regulator rectifier single phase out. We'll connect the white and the yellow together as one connection, and the pink or the red as the other, as the single phase connector into the rectifier, 12 volt rectifier, and let's see what it's capable of doing. So back when I've dug out the single phase rectifier. So see you in a bit. Oh yeah, sorry, I've just got my regulated voltage supply just hooked in to the battery, because obviously I'm not charging, and the coil will be pulling the battery down, because there'll be a couple of amps just for the coil. So that's why that's hooked into there. Okay, so back in a second. So I've got the white and the yellow phases connected together, and the red on its own, into the rectifier, into the 12 volt battery. Got a few high tick over sets on the engine, and we are running at about half an amp, charging the battery up with no load, 13.8, 3-4 volts or whatever. So I'm now going to hook the 60 watt bulb into the system, which should be this one. I'll just put a few revs on it. So nearly 4 amps, and obviously still above the threshold of the the 12.6, which is the float value of the battery. So the battery is still down a bit, still pushing 0.8, 0.9 of an amp in there. So it's charging at 12 volts, no problem. So I'm going to try and hook up the 12 volt coil and see what it draws with the 12 volt coil and the bike running in the system. So I'll be back in a second. Okay, just trying one last thing. I've actually got a 3-wire regulator rectifier. So that's the 3 phases hooked in. And I think this is the winner. So it's charging the battery about 1 amp, and we're already up to 13.8 volts. We'll just try a few revs. So I think that's going to be the winner. So we'll uncouple everything and we'll have a look on the bench. See you in a sec. Okay, so tried a few bits. Obviously that's our original selenium cell, or selenium rectifier, sorry. So I tried the single phase one. It did work by joining two of the phases together, and yeah, probably could get enough to drive what you need to drive on the bike if you stick with LED for the headlight bulb. I also tried a five wire 3-phase. I don't know where I got that one from. That worked as well, about the same as this one, but I did have this thing and I don't know where I got it from. It's just in the box of junk. But this is a 3-phase 5-wire, and when we use this one, yes, we got the highest current or the highest wattage, and it worked quite well. The only downside with this is the size, so I may have to modify it to fit it in the space, but that's the one I'm going to go for. So looking at the wiring, to minimise whatever we're doing in here. So there's the white plug, alternator plug with the 4 wires, so the 3 phases and the neutral. So I'll be plugging the phases of this, so they'll be coming out. I'll just be taping them back into the loom. They're now redundant, just isolate them from each other, and those 3 will be going in. So that's that end, and then we've got the selenium rectifier end, the other bit to this plug, which I'll be pulling out these 2 wires, this one and this one. They'll be redundant systems. Well, in fact I can leave them in, there'll just be nothing on the other side of the plug to plug them into. Then on this one, green is the earth and red is obviously the power, and that's the only mods to the charging system I'll have to make. I may have to make some alterations to the feed into this switch, because what it does when you're running the headlight, it uses like half the phase in AC, battery power plus half the phase in AC to power the dip or the main beam. So I may have to do an alteration in there, so I'm feeding directly off the battery. But in the meantime, we'll do these 2 mods, get this thing fitted somewhere somehow, get it wired in, and we'll have a look at the ignition coil next, because obviously if I connect 12 volts to a 6-volt coil, I'm just going to probably burn it out, but you know, the wiring's going to get hot and everything, because the ohms value will be, you know, double. So it's going to create heat and damage. So let's get this on, sort these few bits out, and have a look if I can get my 12-volt coil to fit in that space. Hopefully it should do, because the coil that's on it at the moment is an aftermarket one. I couldn't get one the right size, but this one looks more akin to the right size anyway. But let's get this bit done, tank off, and have a look. So see you in a second. Okay, there's the battery fitment. So what I've done, I've put the round terminals on there and then made 2 fly leads so I can go back to the original bullet connectors, so the harness is untouched. I also managed to make a bracket for the rectifier, and use the original 2 inhibited plugs just by changing the ends over. So if anybody ever wants to go back to the original 6 volts, they can do. The harness is untouched, and same with the coil. So the 12 volt coil, I just had to put a couple of spacers underneath it because it was a bit close to the frame, and I've just tried it for a spark. So I've got my 12 volt LED bulbs in here now. So there's our ignition on. It's a nice bright spark. Oops. See if the camera frame rates can catch it. So we've got a spark. We've got a neutral light. So I've just got to drop the tap back on, make sure it runs, which is no reason why it shouldn't. And then I'll drop back onto the light bulbs, and I think I've got to make some changes inside the headlight with this unusual arrangement where one of the phases feeds the headlight direct from the AC. Obviously AC on a bulb, no problem, but obviously now I've got all my 3 phases going through the regulator rectifier, and obviously I've just got my straight DC 12 volts coming out, so I will have to make a couple of mods to the wiring inside the headlamp shell after I've worked out what's going on with this thing. So back in a second, folks. Catch you in a sec. Okay, we're fitted. That's us on tick over. Nothing on. So 14.7 nearly. So lights on full onto main beam. Yep, so well over 14 volts with everything on. So I'll just tidy up a bit and just show you the bulbs that I've fitted. So back in a second. Forgot to mention the horn. Am I going to change the horn? No, because I've tried this before 6 to 12. I mean, obviously it's going to be drawing a lot more current because I'm giving it 12 volts, but you only press the horn for seconds, so I'm sticking with the 12 volt horn and it works quite well. So there we go. Okay, catch you in a sec. Okay, so we really are done. There's a bit of redundancy in here, the yellow and the white, not the white that comes back to the headlight, white and blue and green. Green is the ground, blue is the main beam, and white is the dip. But there's also a yellow and a white which come back from the original generator or stator, but they're still left in the loom, but they don't go anywhere. They're taped up because they just don't exist here, and obviously don't exist here because we bypassed this with our new solid state regulator rectifier. So these are the stop and tail LEDs. They pull absolutely nothing, so they're just standard automotive offset pin. They would generally be at 21.5 in an incandescent, but obviously in LED it's in lumens, whatever that is. I haven't got a clue what they are, but very, very low power consumption. Then obviously the neutral indicator, the main beam indicator, and the backlights for the speedo and the rev counter are just these small bayonets, now converted to LED, very, very low power and very bright. I'm not going to strip the headlights out again to show you, but you might be able to catch the H4 LED in there. There is a side light bulb in the bottom, but it just plugs the hole because there is no side light, and there wasn't on this. Obviously there's a tail light but not a front side light. So was it a success? I would say absolutely a success. And is it finished? It actually is finished now. So there is a couple of little things I could do, but really speaking, it's at the maximum whatever it's going to be now. But it is a lovely little bike, and yeah, turned out very well. Anything else on it? Yeah, probably as always, probably spent far too much money doing it, but really enjoyed it. It was a lot of fun. Not done any Jap stuff for long enough, so yeah, out on the lookout now for the next project, and whether it happens before we go away or what, I don't know, but yeah. Anyway, hope you get something out of it. It's well worth doing it if you want a bit of power on the headlight and a bit of better choice of bulbs. It's an easy job and well worth it. So we'll catch you on the next one, guys. See you later.